Okay, good morning class. At this point we're looking at sequence and series. This lesson was given to the grade 12s this morning. However, we were experiencing load shedding at the time. Okay. So we're looking at exercise. Yep. On the previous page, let just get it quickly. Today we're looking at practical applications. Practical applications basically real life scenarios. It is exercise 9 on page. Let me just get that quickly. Okay, so it's basically example 1 on page 21. These examples are for exercise 9 on page 23. Okay. So basically it's marked practical application. As I said, this is basically real life problems. Okay. So firstly we need that up here. So here we are given this diagram. Okay. And below that we are given a similar diagram, but explaining what's happening. Okay. So basically we are told that a large red square has the base of and has the sides of 12x centimeters. The midpoint are joined to form the green square. The midpoint of the green square are joined to form the purple square. This process is repeated indefinitely. So if you see in the sum it repeats indefinitely or to infinity, we know we're going to use at some point the sum to infinity formula. The sum to infinity formula can be applied if and only if r is between greater than -1 but less than 1, provided r is not equal to 0. The question says calculate the sum of the area. So we need to set up a sequence or a series with the areas of all the squares that are formed this way, including the large red square. So taking that into consideration, the reason why I actually put this much lower was I was going to show you how they get those values there. Okay, so just taking that in mind, what they said was the midpoints are then joined. Okay, so if this length is 12x, then this from there to there, of course, is going to give you 6x, and that is going to give us 6x as well. Okay, so what is formed here is a right angle triangle. How do we know it's a right angle triangle? Because that's a square. So with that I will be able to calculate the hypotenuse of that square. Okay, by using Pythagoras. Okay, so the hypotenuse squared according to Pythagoras is going to be the sum of the other two sides squared. So 6x squared plus 6x squared is going to give us 36x squared plus 36x squared, which gives us 72x squared. So the hypotenuse, I apply my square root there, will give me 6 root 2x. So this length here is 6 root 2x. Okay, so I'm going to take this off here. I'm going to put here 6 root 2x. So the process is continued. So again, to calculate this length, there's 90 degrees. Remember that this is again a square. Okay, that is 90 degrees here. That's the midpoint. So that length is going to be the half of 6 root 2x, which is 3 root 2x. That the length is the same, 3 root 2x. Okay, so to calculate the length of the purple, the one side of the purple square, again I need to apply Pythagoras. Okay, however the square is lying this way now. That is 90, and this was 3 root 2x, and that is also 3 root 2x. So again we're going Pythagoras. Here it's again your hypotenuse. So hypotenuse squared is equal to 3 root 2x all squared plus 3 root 2x all squared, which in turn gives us 36 plus 36. Nope. That's 9 times 2 is 18. So 18x squared plus 18x squared is going to give us 36x squared. And the square root thereof, which give me a hypotenuse, is 6x. So this length here, of course, now is 6x. Alright. So to calculate, so basically that's how they get this length here, these lengths here. We spoke about remembering that this whole length here was 12x. Okay, this length there is 6 root 2x, that is 6x. If you carry on, that will be 3 root 2x, and so on and so on. Okay. But remember, the question was with regards to the area. You must calculate the area of if this process carries on indefinitely. So what I'm going to do is I'm going to set up a sequence for the areas of this squares. So if I look at the first one and I work out the area of a square, how do I calculate the area of a square? The area of a square is going to be side squared. Okay. So the length here of the side is simply going to be 12x. So it's 12x squared, which is 144x. Okay. Let's look at the next one. Why am I putting pluses through it? Because that's a series here. Okay. So this length there, what's the length of each side of the square there? It's going to give you 6 root 2. So it's plus 6 root 2x all squared. So that will give us 3672x squared. Okay. Let's look at the third one. The third one is going to be, of course, that one there, which is 3 root 2x. It must be squared. Why? So that's how we calculate the area of a square. Okay? So it's going to give you 9, it's going to give you 18x squared plus. And of course that carries on. If you want, you can extend it further. But from here already we can derive that your A value is going to be 144x squared, and your R value is going to be 72x squared over 144x squared, which is a half. Okay. So it says it's going to be repeated indefinitely. So sum to infinity. Yes, that also indicates that R is between -1 and 1. Sum to infinity is A over 1 minus R. Your A value is 144x squared over 1 minus R, which is a half. If I put in my calculator, 144 divided by 1 minus R, 1 minus half is half. So it's going to be 288 x squared, centimeter squared, if you like. Okay. So that one is fairly simple. Look at the example 2 on page 20. This one is a bit challenging for the learners to understand. We'll go a bit slower through this. This is worked example 2, and worked example 2 is on page 22. I'm not going to do worked example 3. So I haven't seen that question come in the grade 12 exam yet. So it's nice to understand how to do it, but in grade 9 there was another method we showed you how to work out the recurring numbers. You can refer to the grade 9 syllabus. You just find the playlist and you look where you can convert recurring numbers to common fractions. Okay. So we look at work example 2, this on page 22. So before, so at the end of the first year we are told after planting a tree is 1 meter tall. So at the end of the first year after planting, a tree is 1 meter tall. Okay. In the second year, its height increased by 56 centimeters. So firstly, if we look at the initial height of the tree is given in meters, so 1 meter is also equal to 100 centimeters. Also equal to 1000 millimeters, but because they're talking about centimeters here, I'm opting with centimeters there. In each successive year, which means to say each year thereafter, its height increased by 7/8 of its previous year's increase in height. So before we read anything else, what you notice is that my R value is also between -1 and 1. So what do we notice here? You can also, if needed, work out sum to infinity, which is a over 1 minus R. Why? Because the sum to infinity exists if and only if R is between -1 and 1. Okay. Of the previous year increase in height. Okay. The question says determine the increase in height of the tree in the third year. Okay. So if we're looking at the scenario here, the first year the tree is 1 meter tall. In the second year, so 1 meter, which is 100 centimeters, let's work in centimeters, 100 centimeters. In the next year, the height is 156 centimeters. In our third year, it's 7/8 of 56. Why? Because we are told that in each successive year, its height increased by 7/8 of the previous year's increase in height. So, the increase in height of the first year is then 56. So as right there 56, this is increase in height here. Then of course the second year is 7/6 of that, so it's 56 times 7/8. The next year again, it would be 56 into 7/8 times 7/8, which is 7/8 squared, plus and so on. You could have changed that to decimal if you like. It will be easier to work with. So that's going to be 56. The next one is 56 times 7/8 gives us 49 centimeters. The next one is going to be 7/8 squared. What can I just multiply it by 7/8? Gives me 42, comma. So that's 42,875. And so on and so on. So after the first year, it's 100 centimeters. The second year is 156. The third year, I'm going to add 156. I'm going to add 49 to it. Plus 49. Give you 205 centimeters. After the next year, I'm going to then say plus its increase in height, which is 42,875. Which gives us 247,875. 247,875. Okay. And so on and so on. Okay. So you just, the dots meet together and they carry on further. Just coming back to the question, it says determine the increase in height of the tree in the third year. So in the first year's increase in height is 100 centimeters. The second year is 56 centimeters, and the third year is 49 centimeters. Okay, so therefore the third year would be 49 centimeters. Okay. Okay, this is a note to be made at this point. Why did I write this below? As you can see, that this number pattern does not conform, or this sequence does not conform to any number pattern that we are exposed to. For example, you don't have a common difference, you don't have a common ratio there, and you don't have a second common difference there. Can you see that? However, the increase in height, however, this year, which is highlighted here, conforms to a geometric pattern or sequence here. Okay? So that I'm writing it apart because that conforms to a geometric sequence thing. Also with this practical application, or application, sorry, with this practical applications, we tend to write a sequence or a series, okay, so that we can use our formula that we are exposed to at this point. Okay. Let's look at the next question. The next question in number 2 says, determine the total height of the tree after the third year. And that shouldn't be an issue. After the third year, it is going to be 205 centimeters there. Okay, so T3 or third year or year 3 is going to be 205 centimeters or 2,05 meters. Okay, or you can work it out using the formula, which is really not needed, as you can see. Anyway, you're going to work out 205 centimeters because we need to see the pattern that is emerging here. But say you didn't know that, we can say then that term 3 is going to be, remember that this 100 centimeters does not conform to the pattern. Okay, so the first, not T3, the sum of the 30 years. Why sum? Because the previous years, what's the name, will be accounted for as well. Okay, increase in that. So the first year is 1 meter plus. Now from the second year onwards, it actually conforms to a pattern. So if I use that formula, Sn is equal to AR n minus 1 over R minus 1, is simply going to be 56 into R, which is 7 over 8. Now, although it's term 3, 1 is accounted for. It's supposed to actually be 100, yeah? 1 is accounted for, so it's going to be 2 minus 1 over 7 over 8 minus 1. Okay? So it's going a bit cramped here. So it's going to be simply 100 plus 56 into 7 over 8 to the exponent, not 4 over 8, 7 over 8, to the exponent 2 minus 1, and this is all over 7 over 8 minus 1. That gives us 205 anyway. Okay, 205 centimeters or 2,05 meters. That's probably behind the calculator at that point. Okay, but I'm sure you guys get the picture at this point. The next question says, I'll just pull this down here. I just need the pattern maybe. In question 3 says, I'm going to take this off here. Mistaken value. But anyway, we are told that Libello says that at the end of the 5th year, the tree will exceed, which means to say it will be more than a height of 3 meters. Tabu disagrees, which means to say, saying no, it's not the case. With him and says that the tree will only exceed a height of 3 meters after 6 years. So he's saying after 6 years, the tree will be taller than 3 meters. Is either of them correct? Could you justify your answer by means of calculation? So in other words, I need to work out what the height of the tree is after 5 years and after 6 years. Okay, maybe 6 okay. So Libello again is going to be the sum of 5 is equal to, remember that the first year does not conform to the pattern. However, there onwards it does. So we must work out the sum for 5 years. Okay? So after the first year is 100, so we must work out sum of 4 years here. Okay? So that's simply going to give you 56 into 7 over 8 raised to the exponent 4 minus 1 over 7 over 8 minus 1. So that gives us, pull this up here, that basically gives us, let's say again, now 100 into 56, 7 over 8 to the exponent 4. Remember the 1 is accounted for, okay? That's why I'm not putting a 5 here. So that gives us a height of 285, 39 centimeters or 2,85 meters. So is Libello correct? So the answer would be no. No Libello is incorrect. Okay. On the other end, let's go Tabu. Tabu, he says after 6 years. So we're going to work out sum of 6 years, so it's going to be 100 plus 56 into 7 over 8 raised to the exponent 5. Remember that 1 is accounted for. Minus 1 over 7 over 6 minus 1. So that gives us, just changing that exponent there to 5, gives us 3,18, 318, commas 2, 2, or 3,18 meters. So yes, Tabu is Tabu is correct. Tabu, Tabu is correct. Alright, and then the last question, it says calculate the maximum height. So whenever it talks about maximum height, we work out the sum to infinity. It says calculate the maximum height to which a tree will grow. Okay. So again, it's the sum to infinity. So we say S infinity. First, the first year is accounted for. It's 100 meters plus A over 1 minus R. 100 centimeters, sorry, it's A, which is 56, I think.